Hello, everybody. Thank you for making it here on a pleasant Saturday afternoon. I have the difficult task of following up a cost and measuring session with another cost and measuring session. Now, the hard thing about measuring costs and other things in the cloud, and especially with Kubernetes, is like taking an auto in Chennai. So if anybody has ever taken an auto in Chennai, you know what it is like to be measuring costs in the cloud. Something will show in the app, but the auto fellow will demand more, and then you have to pay that. And then after you get to the destination, there'll be a fourth cost that will just be pulled out of the air. And so all of my experience in the past, however many years, with using cloud resources, with using cloud compute and trying to ascertain costs in the cloud has been extremely difficult, irrespective of which cloud provider I've tested with, which is mostly irrespective of which auto driver is driving the auto. Okay, it doesn't matter. It's always bad. It's always horrible. Before all the women in the room start to feel bad, I did remember to include like a women auto person picture as well. So welcome to my session today, everybody. Cloud costs is not a very simple, I install a tool and it gets solved kind of problem. It's a combination of tools, techniques. It's a combination of using your experience and the collective wisdom of everybody who is in your organization. And it's also a question of understanding quite well what it is that you aim to do in the cloud and with your infrastructure and things like that. The actual name of the session should have been this, but given that I wanted my paper to get selected first of all, and I didn't want to alienate anybody in the audience, I left this. Everybody has seen this meme, right? So it's quite popular. It's quite evident from all of the reactions I'm getting that people understand and relate well with what is going on. And it's very hard to determine objectively what it is, like I said, your cloud resource is going to cost, given what you're trying to accomplish in the cloud. So in the session before, I wanted to start with all of these questions. What does your infrastructure cost? Who knows? Blah, blah, blah. All that has been asked. Obviously, nobody knows the answer, so I'll skip all of that. But here's the thing. For me, it starts in a cultural underpinning. We were all known as programmers. At least when I started to work, I was known as a programmer. I was very happy, okay? And then they said, we all have to be software engineers, okay? Engineer, I don't know what it is, but anyhow, that's what everybody decided, okay? And then they said, no, you all have to be developers, okay? So something changed, okay? And then there was this new breed of people known as operators. Some people who were in my department got transferred to another one. I didn't see them after that. I was only like using IM. I don't know if anybody uses IM anymore, but like IM is the Microsoft Teams of 15 years ago. Nobody knew how to configure it. We all hated it, but we all used it because the office said we had to use it, okay? Then they decided that we all needed a promotion and they decided to call all of us DevOps. Why? Because they wanted to make us do more work and pay us the same. That's what I think. Your opinion might differ. So it was two different responsibilities, then it all became one title. But after 15, 18 years of doing all of these different things, what I realized is people will keep changing the name from time to time. You're going to be called different things, different times. Maybe this event will be called Platform Engineering Day next year, I don't know. But remember that it's all good marketing. We are all sysadmins at the end of the day. We're either fixing problems with our computer or something in the cloud or something somewhere else, but we're all like glorified sysadmins, okay? They'll give us a Mac. They won't make us go into the server room and keep us in dark offices and things like that. But that's not really the point why we are here. Now, the whole notion of DevOps is starting to expand more. They decided to call it DevSecOps as if Dev and Ops responsibilities were not sufficient. That really made me sad. And now they've invented this new term and want all of us to participate in it. And there's so many sessions that we have to go to. There's so many people I have to speak to. There's so many new training and other courses that I have to take. And I just feel like there's a Tamil saying, Kuruvi Talaila Pananga. And it's a very scary pumpkin. That's really how I feel about this whole shift. But that's the underpinning as to why, as programmers and as DevOps or whatever you want to call it, as glorified sysadmins, why we need to be able to answer this question, right? It's not about knowing how much we are spending, but it's also about suddenly your manager will come to you and say, or they'll post in Teams or Slack or whatever it is you use, right? And they'll say, how do we reduce cloud spend? Somebody somewhere decided that, okay, let's reduce this cloud expenditure. Why? Nobody knows how. Absolutely nobody knows. But somebody decided to do that, right? And we don't know, right? As engineers, you can, if somebody came to you and said, okay, can you read this documentation and check how to write this new service in TypeScript? Maybe you can do it. If you have to rewrite an old Java service that is working perfectly into Go, you can work hard and do it, right? But what do you know about cloud spend and why do you care? And then there's people that come and say stuff like, let's use Kubernetes. Why? Because nobody knows. Nobody understands Kubernetes fully. They just read something somewhere, and then the answer that I hate the most is, oh, Google uses Kubernetes, so let's also try to use Kubernetes. No offense to the Kubestronauts and the golden Kubestronauts in the audience, okay? But people just want to do a fad. And then after this, you'll jump on the Kubernetes hype train, and then after a few months or a year or two, they'll come to you and ask how to reduce Kubernetes cost. Best way is you already know the answer. Don't use it. And you'll be like, I already told you this when we started talking about it, but you wouldn't listen to me. But you can't say that, that whole salary, what's that cycle called? Where they evaluate you for the next appraisal cycle. Thanks. So your appraisal cycle is coming and you don't want to do it. So I don't want to make blanket statements like that. Kubernetes as a technology is great. I love the CNCF. I do a lot of work with them. So the thing is, or I don't know if I'm allowed to say that also, but the thing is you have to learn to self-evaluate. And when I said self-evaluate, last time somebody laughed in the audience. Evaluate, okay? So you have to find out why do you need Kubernetes for a small number of services? Does what you're writing actually require the use of containers? And does it actually require the use of a container orchestration tool that is quite complex? And once you use that container orchestration tool, there's 95 other CNCF landscape projects that you have to integrate, which you cannot without a Kubestronaut certification or something like that. So it's extremely hard to make this decision to objectively use a technology without knowing about it fully. And it's very hard to know about it fully also. So you're making like blind decisions, you're just taking one step in front. But the idea is there's a lot of workloads out there that are not containerized, that are working perfectly fine. There's also a lot of workloads out there that are not on Kubernetes and they also work perfectly fine. So it's okay not to be on the hype train. Now, when posed with things like this, like when posed with the question, how do we measure Kubernetes costs? How do we control Kubernetes costs and things like that? What do you all do? I'm an old-fashioned person. I still use web search, okay? I read from this lovely old website known as Stack Overflow. I don't think the only people nodding in the audience are 40 years or above, okay? And then there's a new trend about reading shit from Reddit. Yeah, but be careful. Because they'll say they're from JP Morgan or something, but they're just like 2-bit scammers, okay? And the part that I don't like is like YouTube influencers and what they have to say and anything. But anyhow, they're all there. And then there's this new thing that I won't talk about, and you'll use your like favorite little tool to ask. Your manager will ask you and you'll pretend to know something. And that's exactly what that tool is also doing. It's just pretending to know something. It doesn't know squat about your infrastructure, about your apps, about your workloads, or about the thing that it's even talking about. It's just spitting out a random set of words, and it makes sense to you because even you don't know what it is that you're actually searching for, okay? So I'm not against modern tools in the workplace, but know that it's not the right way. It doesn't know things, okay? You can still use it. Use it and, I don't know, give your data to Google or whatever, right? But every time you ask it, it's going to give you very basic answers, okay? It's like artillery for me. I'll give you examples. The first, you can try asking your favorite generative AI tool how to reduce Kubernetes cloud spend. Don't do it now. Do it after the session. And it will give you an answer like this. Make sure you do accurate capacity prediction. Okay? If I was able to predict capacity accurately, I wouldn't be working this shit job, first of all. And then the next thing that it will say is, you can check it out. It will do, say, resource right sizing. You can do resource right sizing if and only if capacity, and you can predict capacity accurately. So that's another very stupid answer that this generative tool will give you. Then one of the other popular answers that you'll get is use autoscalers. As if, so using autoscalers requires the knowledge of some YAML. Again, you might all not be kubestronaut. I keep saying kubestronauts. The reason is it's like a certification that the CNCF gives. Everybody here knows what a kubestronaut is? Yeah, they get like a special blue jacket, but they also know a lot of things. And there's a couple of kubestronauts in the audience. Can you raise your hands? Kubestronauts. Yes. And they'll always sit together in an event, okay? They'll always sit together close to each other because they'll form like a clique. And as if kubestronaut was not enough, there's something called a golden kubestronaut, okay? And you get one hoodie also. Chennai kedukkinga sweater. Avlo panaka Chennai sweater podra alavu panakaranga. That's the golden kubestronaut. Please give him a big hand. It's not easy. You have to pass 15 exams or something like that, and you have to know like a whole bunch of different tools. If you're in the Kubernetes ecosystem and you want to know a lot of like CNCF stuff, I highly recommend speaking to Dini Babu and some of the other kubestronaut, Ashok and the others. It's very useful. But anyhow, auto-scaling. So you really need like an advanced degree in Kubernetes to be able to write the write YAML so that your auto-scaling actually happens. Then you can determine if and how you need auto-scaling depending on the resources and the resource right sizing, which again depends on capacity planning. So your generative AI tool will give you a lot of advice that, again, is not really actionable. Who will be happy with this? Your manager. Because even they don't know what they're asking and they don't know the answer to the question. So if you say, G, in the mono vishayam panla, G, they'll be like, okay, that's the next 3 months of your work, right? So very happy employee, happy manager, all of that. But the problem is none of that is quite actionable. Okay, so what is actionable? This is the fourth thing that you'll get. Use spot instances. I just feel like breaking the computer. Anybody who comes and says use spot instances, in my opinion, deserves a slap. People know here how spot instances work? Yes? Yeah, it will turn off. Okay, for those who don't know, spot instances are like a special price discounted cloud instance, which is basically not used. And the cloud provider is allowed to shut down your instance whenever they want to, basically. If your generative AI is giving you this advice, or if you're a manager and your employee who checked generative AI gives you this advice, give them 0 in this year's appraisal review. Okay, say Ram said so, and go contact Ram about why that's a problem. But anyhow, these are all of the different problems with very generic generative AI responses. Okay, what you really need to do, and this is like the non-generative AI section of the whole talk, what you really need to do is first be able to measure accurately what's happening with your infrastructure. And the way you do that is by using some kind of sandbox or some kind of staging instance and then run your workloads. Basically, you do some testing, right? So you have a pre-production, you have some staging, you have something, right? So start measuring from this stage itself. And then you can think about controlling, and then you can make accurate predictions and things like that. But how do you go about doing all of this? Because you have never heard of something like that. And that's where the tool of choice that I'm going to talk about comes in today, which is OpenCost. So OpenCost is a CNCF. Those like 1 million tools inside the CNCF ecosystem. OpenCost is one of those, and it's fully open source. You can install it on any kind of Kubernetes cluster. I'll even go one step further. Even if you're not in the business of using Kubernetes or cloud native and all that, you can still install OpenCost on your cloud infrastructure, and it will let you accurately measure your costs. Now, if you're too lazy to type the word OpenCost in your browser, you can use this QR code to scan and get to the project page. It basically, so If I try to explain this to like an audience, everybody will like, oh, I use it. You remember the guy from the third slide who let his EC? This is his architecture basically. But this is how OpenCost is on AWS, okay? But basically it's just two things. And that's what we'll focus on today. There's a Prometheus instance and there's an OpenCost instance, okay? So for purposes of today's demo and today's conversation, I'll focus entirely on OpenCost on a Kubernetes cluster, but please know that all of these concepts apply equally well to any kind of cloud infrastructure that you're utilizing. Now, like I said, there's going to be a Prometheus that you have to install or use a Prometheus that you have access to. It might be on AWS, it might be your own, it might be whatever. And then there's an OpenCost instance that you have to install as well. On Kubernetes or cloud native infrastructure, they're both available as Helm charts. You can quickly install them and get set up. On non-Kubernetes infrastructure, there's a few more additional steps you have to take in terms of installing these two and connecting them, etc., which is not extremely hard because I know you're competent engineers and you love your job, which is why you're here on a Saturday to talk about SRE and DevOps. I have a running instance, obviously, because I don't trust things to work on the fly. Let's see if it is actually running. So I'm running all of this stuff locally. I don't have it connected yet. So let's see. So this is my Kubernetes cluster. And if you look here, I have a Prometheus installed. I know it's a little hard to read from the back, but do your best. And this is my OpenCost pod. Okay, so like I showed you, there's two pods. There's a Prometheus, not important for this. And here's my OpenCost pod. So OpenCost will run as a pod inside my Kubernetes cluster that I'm trying to measure. And it will basically take all the metrics from the Prometheus and convert that into data that is a little more actionable. Okay, now let's see. I'm going to port forward this so that I can access the thing from my browser. And so this is the OpenCost UI. Now, I wanted to run this for a week before the conference and then show more data and lots of data and things like that. I'm just as lazy as any of you, okay? So I just got it running today. But what I like about OpenCost is it gives me data about what my costs are in a very granular fashion, okay? So now I can see some stuff per namespace. I can see, so if you want to measure how much did a pod cost me, for example, I can go break this down by pods. And then there's an idle instance that's taking up like most of the thing. But then the idea is if you have individual pods, you can measure exactly what that individual pod is costing you. Now, there are ways in which you can measure granular costs on an AWS, on Azure, on what else am I forgetting? GCP, yes, sorry, and DigitalOcean and all of these different things, okay? But I have not seen a tool that can give it to me by namespace and give information to me broken down by pods and things like that. So that's something that I find really useful. And so if the way this cost thing here works is here it's all made up, but OpenCost can do an integration with your cloud service provider. So when you give it the API key and everything during installation or a subsequent configuration step, it will actually go to your cloud provider and get the cost value from the resource that you're trying to use and then multiply it and then display it here. Okay, so it's capable of giving you a very accurate representation of what the exact cost is. And then obviously it breaks it down into percentage and things like that. Now you can, like I said, you can break this down and you can do different currencies and everything, but that's not important. We don't care. Now, you don't just have the need for measuring what a running thing is costing, right? One of the other things that I tried to do with this is so like I was saying, this can connect to your thing. And so I tried to do something else. This is running on a kind cluster. I added what is known as Cloud Foundry query, not just because I worked there, but because this project allows me to do a build as a pod. Okay, and I'll show you an example of that. So let's see, let me stop this for a second. So if I go to this Go application, for example, and then I do first, I give this app name. So it breaks down a deployment into very simple terms, but that's not the fun part, okay? So if I open my CLI, this is a build pod. So it does a build as a pod. So what I can do with this combination of tools is I can run a build which becomes a pod, and then I can measure everything about that pod with Prometheus, obviously. But most importantly, I can predict what that pod is costing me in order to set up. So the build pod will give me a cost of the build. Measuring the running pod will give me an idea of the running cost. So this will build, and then once this completes building, it will become a running pod, okay? So I ran one of these before, and you can see that it will become a running pod. So once it becomes a running pod, I know how much it costs to run it, and then I know how much it costs to build. That way, OpenCost is extremely efficient in telling me exactly what those costs are and predicting those costs. Let's see. Where was my port forward? So if I open my browser to OpenCost again, it will, and if you can read alphanumeric, it will tell you exactly what that particular pod costs in terms of the build, etc. So I find these strategies to be very important in order to be able to answer those questions that we started off with, okay? So that's the demo of using this with that. This is the list of providers that OpenCost already integrates with. So it has all your providers, which is why I tested it on like DigitalOcean. But also what's important is if you want to do like open source contributions and things like that, it's a good project. They need a lot of help. And then I know I wouldn't speak about AI a lot in this session, but there's a huge plugin architecture, and you can write a lot of plugins either for work that you want to do or you want seen. And so there's an OpenAI plugin that lets me measure LLM model costs and things like that. And I tried to deploy like an LLM model to this. I don't know if it completed deployment. Yeah, so there is an LLM model here. So I think people can recognize the name. It's a 7 billion parameter model. And if I start to run this long enough, I can start to see how much it will actually cost me. So it runs as a pod on my infrastructure. And so it should be able to measure how much that's costing. So anyhow, that's really what I was going for here. So yeah, lots of useful stuff when you're using OpenCost. And the last couple of questions that I wanted to end with is, a lot of this is again reactive, but is there a proactive approach? There isn't a one-size-fits-all approach. You really have to design the approach for yourself. And I don't know what that approach will look like for each of you, because it involves a lot of knowledge about what your infrastructure is, and like I said, what your applications are and what it is that you're running. But I think if you start using OpenCost and use it early and then start measuring what it is, it will give you an idea for what your proactive approach to costing can look like. But that being said, I don't know exactly what that will look like, but I'm sure you'll look like this when you finish designing it. That was my talk today. Thank you so much for being a patient audience. Hopefully you learned a little bit from what you saw today. I'm very happy to answer questions later during the break and things like that. I'll be around all day. Don't hesitate to reach out. I'm happy to shake hands.